Okay, so the fundamental theorem of calculus, which you learned a long time ago, says that the definite integral of f of t dt is g at the right endpoint minus g at the left endpoint if g is an antiderivative of f. Okay, so now we have a similar statement for a curve, r of t, call that the curve C. The line integral of f dot dr over that curve is some function phi at the right endpoint or at the final point minus phi at the initial point. If phi is an antiderivative of the vector field f, which we interpret now as the gradient of phi equals f. And in this situation, we say that phi is a potential function. And f is conservative, which is not a political statement. It just means it has to do with conservation of energy and other principles. Okay, so as a practical question then, if you're given an integral like this, can you use this theorem to evaluate it? So first we have to say, if you're given capital F, is it conservative? In other words, does phi exist? Okay, in 2D, there is a necessary condition. It requires that the y derivative of the first component equals the x derivative of the second component. So here f is just a two-dimensional vector field, f1, f2. Okay, if that's not true, you can't possibly have a conservative field and you can't use the theorem. And then the other practical question is, given capital F, given the field, can we find its potential? So we know it exists, but can we find it? And that's an algorithm that you'll see by examples in class. Now, there are two important conclusions that come out of this theorem right away if f is conservative. So if f is conservative, so first of all, that line integral, the value doesn't depend on the path. Because it only depends on the two endpoints, right? So no matter what the path is between these 2 points, you're going to get the same result. And then the other fact is that the line integral is 0 if C is a closed curve. Right, and that stands to reason. If C is a closed curve, that just means that the end point is the same as the starting point, so these two terms are the same and they cancel out.